Domain and range. Domain's list of the x values, range is the list of the y values. Solving equation, we ended with one answer. So this goes back, when we're solving equations, generally we're just looking for an x value, but of course now we're looking for possibly two values, x and y. Oh yeah, so, and we talked about this. Now when we graph, the line represents an infinite number of values that if you were to make them ordered pairs, would make the equation true. And that's the nice thing about seeing two variables in an equation like we would with y equals mx plus b. Hopefully that one seems familiar. The interval notation, it shows a range of solutions for an equation. That's true, we just want to see the solutions. Sometimes though, we may use inequalities to show values that don't work, and that's fine too. You'll need to remember though that if you're using parentheses, that it tells us values that are not included in the range or domain, which means they would make the statement false, but it also tells us where it transitions from being false to being true. The same thing is true with these ones, the square brackets, but that tells us that the ends are actually valid. They make the original equation true. So values can go to negative infinity as well as positive infinity. If that happens, we just have to use parentheses with infinity. So yeah, we use parentheses since those values are not included. Hopefully it will once we get started. For a domain and range on graphs, if we have to graph them mostly, we'll use interval notation to express the domain and range. But if we do, we still may use the graphs to do it. On graphs, just in case you don't remember, if we use the square brackets, it means it was a closed circle. If we use regular parentheses, then it was an open circle. If we're just listing a set of values, then we'll use these. Fancy brackets, which we may use for set notation as well. So right here, find the domain and range. We already, well, hopefully remember, because we just saw it a couple slides ago. Domain is the x values. And the range is the y values. So the domain, don't worry about the shape of the line necessarily, but we do want to see for the domain, we're really looking to the furthest left point and the furthest right point. We're looking left to right, okay? So I don't care that it goes up and down for my domain. So how far to the left does this thing go? I can see it goes as far to the left as -5. So the furthest to the left we can go is -5. The furthest to the right we can go on this line is over here to 1, right? So that's my interval right there, which I think it wanted. And we can see over here at -5, it's an open circle, which means -5 is not actually part of the domain, but everything to the right of it is until you get to 1. Then we have the closed circle, so we're expecting to use the square bracket. Now again, this is an interval. It is not a ordered pair. So this tells us that everything between -5 and 1 is good, and then the endpoints, -5 is no good, 1 is good. And just again, -5 is not included because it's open. If it's open, that is how we communicate mathematically that is not included in either the domain or range. So the range is just y values, so we're looking at up and down. Okay, how far up and down does this thing go? Actually, you should start with down, because that would be the furthest to the left. Well, to the down, this goes as far down as -3. It goes as far up as +3. Okay, but again, are these endpoints included? Well, the -3 is not included because it's an open circle, so that's an open bracket. The 3 up here, though, is a closed circle, so it is a square bracket. I just want to emphasize this. If this line in between here had gone all weird like this, it wouldn't matter. That would not change the domain or the range.